Hello there. So this is practice question number 7. Now, this is a kind of interesting question. I think it says if 3, 2 is on the graph of y equals f of x, then it says give the coordinates of the points that must be on the graphs of the following. Now let me interpret 3, 2 for you. Now when you say 3, 2 is on the graph of y equals f of x, now this means that when x equals 3, then f of x, that is your y, which is f of x, f of 3 equals 2. So let me go over that again. 3, 2 means when x is 3, my y coordinate is 2. And you know the y coordinate is just the same thing as f of x. So it says when x is 3, then the f value of 3, that is f of 3, equals 2. That is exactly what it means. Now, looking at what we have here, this is the only information we are given. We are only given that when x is 3, f of 3 equals 2. That is, I can only find the function value when x equals 3. I can't find for any other one because I'm not given for any other one. This is the only information I'm given. So we want to find the coordinates of the point that must be on the graphs of the following here. Now what we have here is a capital letter F, or the uppercase F of x, equals the function of x plus 1. Now note that this and this are different. This is lowercase, this is uppercase here. So we are told f of x equals f of x plus 1. Now how then do I do this? Now since I'm only giving the function value at 3, that is when x equals 3, then I can use this. Since if I say when x equals 3, when I substitute 3 into here, then I can find the corresponding value of this function. So that is my f of 3 is just going to be, so whenever you have x, you replace it with 3. So this is just going to be f of 3 plus 1. So since I know f of 3, which is this, so this is just going to be f of 3 is 2 plus 1, that is 3. So with this, I've been able to know a coordinate that lies on the graph of this function. In other words, for this big function here, we found out that when x is 3, my big f of x is 3. So this is a coordinate of the point that must be on that graph. Now, but for the next question here, we are told that big G of x equals f of x plus 1. Now, how can I use this function here? Now, you would also recall we are only giving the function value for 3. We are giving for f of 3. So how can I make what I have here to be or to turn to 3? In other words, how will I make my x plus 1 to be 3? So let's solve this. So this becomes x plus 1. So we deduct 1 from both sides. So this becomes 3 minus 1. And then we have x. So this crosses out. So we have x equals 2. So that implies that whenever I set my x to be 2, then I can find f of 3. In other words, to be able to use this definition, I must make my x to be 2 so that I can find the corresponding value of x. So I'm going to say when x equals 2, then let me find g, or let me say g of 2, which is equal to f of, so it becomes 2 plus 1, so plus 1, and then this is just going to be f of 2 plus 1 is 3, and then that is going to be 2. So when x equals 2, my big G of 2, we found it to be 2. So a coordinate is just going to be 2. When x is 2, big G of 2 is 2. So this is a coordinate of a point on the graph. The same rule applies for the next one here. We are only given, so I'm going to write that here. So we are given f of 3 to be 2. This is what we are given. And then what I have here is f of 2x. So my question is, or my bone of contention is going to be, how do I make this my 2x, how do I make it to be 3? Because when it's going to be 3, then I can find f of 3, so I can use this function. So that means you want to solve, I want to see how do I make 2x to be 3. So to make 2x to be 3, I divide both sides by 2, and then x equals 3 all over 2. So that implies that when I make the substitution x equals 3 all over 2 into this place, then I can find f of 3. In other words, when x equals 3 all over 2, then p of 3 all over 2 is going to be f of 2 times 3 all over 2, that, and then f of 2 times 3 all over 2, this crosses this, so this is just going to be f of 3, and f of 3 is 2, which is 2 here. So that means p of 3 all over 2 is 2. That is p of 3 all over 2 is 2. Now what this implies is when x is 3 all over 2, p value is 2. So when x is 3 all over 2, the p value is 2. So this is a point on the graph. And then let's look at the last one. Now here it says that's big H of x equals f of negative x. So similarly, since we are only given the function value of 3. So I want to see how will I make negative x to be 3. So I want to make negative x to be 3. So what do I do? So you could just divide both sides by -1. So this goes off. So your x equals -3. So that implies that when I make the substitution of x equals -3 into here, then I'm going to have f of 3. So I can use what I'm given. So in other words, let's solve this. So we have when x equals -3, then we have h of -3, h of -3 equals f of -3. So let's just put this in bracket here, and then this is going to be f of negative is positive, so this is f of 3, and then f of 3 is what we are given, which is 2. So therefore h of -3 is 2. So what I've been able to show now is when x equals -3, the function value is 2. So when x equals -3, the function value is 2. So this is a coordinate of a point on the graph of h of x, and then that completes the problem. Thank you.